Okay, this is example 4 in the book. This is a slightly more complicated example. It's not really hard at all. It's just that there's a few more things to keep track of. And what it is, you have this strength of W14 by 38 rolled steel beam. Okay, so that's this thing right here. This part right here is this beam. Well, you're going to strengthen it by welding on this big blob onto the top. It's actually not even that big. By this 9 inch by 3/4 inch piece of steel on the top. And we're supposed to determine the moment of inertia and radius of gyration with respect to an axis which is parallel to the plate and passes through the centroid of the section. Okay, so what does this mean? So this right here is the centroid of the beam, right? And then this right here obviously is the centroid of that little thing right there. Well, the first thing that we need to do is determine this centroid value right there. So how do we do this? Well, this is a chapter 5 problem at this point, right? So I'm going to call this member 1 and this member 2. Okay? So you remember we're going to say the area, so area of 1 is going to be what? It's going to be base times height. So 9 times 3/4, which ends up giving you simply 6.75. Okay? Area of 2. What is the area of 2? Well, you could kind of guess at it, or more importantly, you could go through and just look it up. And this is one of those things. I'm going to switch over to this book, and you notice here we have this one. It's right. Well, I'm not going to be able to. I don't think this will show up right. Yeah, I can kind of show you. Right here. This is the W14 by 38. So the area is right there. It's 11.2 inches. We're going to turn around and we're going to need this distance. Oh, that was on accident, but kind of helpful. And this distance, and we'll also need the IX and whatnot. So let's go back to the other one. Area 2 is simply 11.2 inches squared. Okay, so then what is the y bar of 1? Well, it's going to be, if we're assuming that this is a 0 point right here, which just makes life a little bit easier. It's going to be half of 14.2 or 14.1, 1/2 of 14.1 plus that goes from here to the bottom of this, and then plus half of the 3/4 plus 1/2 of the 3/4. So y bar of 1 ends up being 7.425, and y bar of 2 is just 0 because we defined it as at the centroid of that thing. So that's kind of convenient. So now we're going to make up this little chart. We're going to refer to figure 1 and figure 2, and then the sum of them. Sorry, if I can remember how to do the sum sign. There we go. Okay, so we have the area. So the area of 1 is, we figured it out up there, it's 6.75. The area of 2 is 11.2. So when you add them up, it's 17.95. Y bar of 1, we figured out right here, 7.425. Y bar of 2 is 0. You don't have to add them up. Doesn't matter. And then we have the y bar area. So in other words, 6.75 times 7.425 is 50.12. Multiplying by 0 is surprisingly easy. Adding to 0 is surprisingly easy. 4.12. Oops. I say it's easy and then I mess up. That's a nice touch. Okay. So y bar is what? It's the sum of the y bar area over the sum of the area, right? So it's 50.12 over the sum of the areas, 17.95. So y bar is 2.792 inches. Okay, so that's not the answer. They didn't even ask for that. So why am I circling that? What's important? That is where this spot is right here. This spot, so this distance right here is 2.792 inches. Okay, so now we can start doing what was actually asked for. So we have to figure out the IX and IY of each one, and then we add them together, right? So let's look at IX of 1. What is the IX of 1? Well, it's the 1/3 or 1/12. We're going to use the parallel axis term, so it's going to be 1/12. It's really tempting to use 1/3 because we use it so often, but remember, for the parallel axis theorem, it only makes sense if you're going through the centroid of the object. So 1/12 bh cubed, the base is 9, and the height is 3/4, and then plus d squared a, right? D squared, I'll just write it like that the first time. So it's 1/12 times 9 times 3/4 squared, cubed, sorry, 1/3 bh cubed, plus my area. I'm going to put this in reverse order. My area, I've just figured it out right here, is right there, right? So 6.75. Now, what is my distance? My distance is how far is the centroid of this object moving to get to that point right there. Well, we figured out what it is. It's gonna move. So the centroid was at 7.425 inches, right? But it's gonna, that's 7.425 from this axis, so it ends up being 7.425 minus the y bar of the whole thing, which is the 2.792. And remember, all that is squared because it's the d squared a. So that gives us what? That gives us that Ix of 1 is 145.2 inch to the 4th. Okay, so that's the first one. Now Ix of 2 is a little bit easier. 2 is what? How do we find that out? Again, we go and we look it up. And switching over to this again, we say, hey, I don't know the Ix right here. It's given us 385. I can't really highlight it. Hopefully you can see that. 385, right? So we come back here, and we say it's 385 plus d squared a. Well, we know the a. Again, the a is at 11.2. Okay, so what is the d squared? Oops. The d squared is from its original centroid to where it is now, which is a 2.792. So it's equal to 385 plus the distance, which is 2.792 squared times 11.2. Okay, and that Ix2 gives you 472.3 inches to the 4th. So when you add them up, so Ix of the whole system is Ix1 plus Ix2, so it's going to be this 472 plus 145. It works out to be 618 inches to the 4th. And that is the answer for part A. So we changed our Ix value from 385, and by just welding this little thing onto the top of it, we almost doubled it to 618. So it's not almost doubled, but you get the idea. It's increased a lot. But we're not done, because we also are supposed to determine the radius of gyration. Okay, so how do we figure out the radius of gyration? Well, that's actually really simple. It's just, you just remember that kx is the square root of Ix over a. So it's just simply the square root of 618 over the area. What area? Well, in this case, it's both areas. This is 11.2 plus 6.75, but we already added up, right? It's right here, right? So that's over 17.95. So it turns out that that is equal to 5.87 inches. That's equal to kx. So again, we just found the answer. Now notice we didn't do any of the IYs or KYs. It's just because it wasn't asked for, right? But it would be a different answer. The beauty of the Y's is both of them are not moving relative to the Y-axis, and so it would actually be pretty simple. But that gives you your your moment of inertia and your radius of gyration with respect to the x-axis that passes through the centroid.